Alright guys, hi, welcome aboard. Today we're going to be tackling the day 2021 of this Advent of Cyber from TryHackMe, right? So, looks like we're going to be looking into some reverse engineering here, and that's good. So the title is Help Me, I'm reverse engineering. Yeah, sure. Help is incoming, right? The story. So MaxKitty's alert dashboard lit up with an unusual alert. A file sharing web application built by Glitch had triggered a security warning. Glitch had been working hard during the season's SOC mess after the last scare with the Yule log exploit, but this new alert caused MaxKitty to question his intentions. So MaxKitty began to investigate. It seemed the source of the alert came from a binary file that made its way to the web app's backend. It did not belong there and had some anomalous activity. The binary was compiled with .NET. This whole setup seemed quite unusual, and with Glitch working on the latest security updates, MaxKitty was filled with suspicion, right? As MaxKitty continued her investigation, Glitch rushed into the room. I swear I did not put it there. I was testing defenses, but I wouldn't go that far. MaxKitty reassured them. This doesn't look like your work. Let's get to the bottom of this. Put on your decompiling hat and let's see what we're dealing with, right? So the learning objectives here are understanding the structure of a binary file, the difference between disassembly versus decompiling, familiarity with multi-stage binaries, and practically reversing a multi-stage binary. Okay, so we're going to be needing an attack box today, and they're also going to be providing us with some credentials, right? So let's start this machine already. These are the credentials, and let's read through Introduction to Reverse Engineering, which I have already completed some modules in regards to reverse engineering. I used to use Ghidra. Basically, I had my own virtual machine, Windows OS, right, where I could safely just interact with this binaries, and yeah, that's because I followed before the offensive pen testing learning path from TryHackMe, and they had some modules and some CTFs also that involved doing some reverse engineering, right? So that being said, let's move on. Reverse engineering, RE, is the process of breaking something down to understand its function, right? In cybersecurity, reverse engineering is used to analyze how applications or binaries function. This can be used to determine whether or not the application is malicious or if there are any security bugs present, right? So this looks like a one of the decryptor. What happened? Your files have been encrypted. Okay, yeah, basically this looks like a ransomware attack, right? For example, cybersecurity analysts reverse engineer malicious applications distributed by attackers to understand if there are any attributable indicators to associate the binary with an attacker and any potential ways to defend against the malicious binary, right? A famous example of this is the WannaCry ransomware in May 2017. Security researcher Marcus Hutchins reverse engineered the ransomware application and discovered a specific function within the application where the malware wouldn't run if a particular domain were registered unavailable. So Marcus then registered this domain, stopping the global WannaCry attack. This is just one of many famous cases of reverse engineering being used in cybersecurity defense, right? So then the binaries. In computing, binaries are files compiled from source code. For example, you run a binary when launching an executable file on your computer. At one point in time, this application would have been programmed in a programming language, such as C Sharp. It is then compiled, and the compiler translates the code into machine instructions, right? So binaries have a specific structure depending on the operating system they are designed to run. For example, Windows binaries follow the portable executable structure, whereas on Linux binaries follow the executable and linkable format, ELF. This is why, for example, you cannot run an .x file on Mac OS, right? Yeah, that's bollocks. With that said, all binaries will contain at least a code section, a data section, import and export tables. So the code section, this section contains the instructions that the CPU will execute. A data section contains information such as variables, resources like images and other data, right? Import and export tables. These tables reference additional libraries used, imported or exported by the binary, right? Binaries often rely on libraries to perform functions. For example, interacting with the Windows API to manipulate files. Okay, so the binaries in today's task follow the PE structure. This structure will be explained throughout the task. So disassembly versus decompiling. When reverse engineering binaries, you will employ two primary techniques. This task section will introduce you to the disassembly and decompiling, explaining the key differences and their pros and cons. So disassembling a binary shows the low-level machine instructions the binary will perform. You may know this as assembly because the output is translated machine instructions. You can see a detailed view of how the binary will interact with the system at what stage. Tools such as IDA, Ghidra, right, and GDV can do this. Yeah, I've used the last two. I don't remember if I used IDA before. I might have. All right, but I just, yeah, just I haven't been doing this recently, so it's gonna be a good module to refresh something. This particular module from TryHackMe, right? So decompiling, however, converts the binary into its high-level code, such as C++, C Sharp, etc., making it easier to read. However, this translation can often lose information such as variable names. This method of reverse engineering a binary is useful if you want to get a high-level understanding of the application's flow. All right. Okay, so what are we looking at here? There's the main console write line. You are writing, just printing this particular message, try to sleep, string address, and then you have this address, right? And then text, you have this path, combine environment, get folder path, environment, yeah, blah, 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 try, catch, yeah, sure, console, thread. All right, so there are specific circumstances where you would choose one method over the other. For example, decompiling is sometimes a best guess based on the tooling you have used and does not provide the actual full source code. Okay, a table outlining the key differences between the two has been provided below. All right, so moving on, table outlining the key differences between the two has been provided below, right? Comparison, disassembly, and decompiling, right? So the comparison when it comes to readability. So in disassembly, it requires knowing assembly and low-level knowledge of computing concepts. And in decompiling requires familiarity with programming and logic, right? Level of output in disassembly is the translated output is the exact instructions that the machine will perform, right? Machine level instructions. And then in decompiling, the translated output is often a best guess. The output may not be accurate and useful information such as variables, function names, etc. will likely be lost. And then comes difficulty. The difficulty can be considered higher as the machine instructions are translated into assembly. Okay, when it comes to disassembly, right? Yeah, I could see why that might be the case, right? Higher as the machine instructions are translated into assembly, which is just machine code, right? It's not. I don't find it pleasant to read assembly code, to be honest with you all. But I understand you have to understand it, right? The machine instructions are translated into a high-level language, which makes them easier to understand if you are familiar with the language the binary is written in. That's when it comes to decompiling, right? And then for disassembly in the usefulness, the entire behavior of the binary can be studied given enough time. And then in the decompiling is a quick way to understand some of the logic of the binary, right? Quick way. All right, multi-stage binaries. So recent trends in cybersecurity have seen the rise of attackers using what's known as multi-stage binaries in their campaigns, especially malware. These attacks involve using multiple binaries responsible for different actions rather than one performing the entire attack. Usually, an attack involving various binaries will look like the following. Stage 1, Dropper. This binary is usually a lightweight, basic binary responsible for actions such as enumerating the operating system to see if the payload will work. Once certain conditions are verified, the binary will download the second, much more malicious binary from the attacker's infrastructure. Stage 2 is when it comes to payload. This binary is the meat and bones of the attack. For example, in the event of a ransomware, this payload will encrypt and exfiltrate the data. Okay. I understand that. Sophisticated attackers may further split actions of the attack chain, lateral movement, into additional binaries, right? Using multiple stages helps evade detection and makes the analysis process more difficult. For example, a small, more harmless initial binary is likely to evade detection by email filtering than a fully fledged binary that performs malicious actions such as encryption. Additionally, splitting these functions into multiple stages gives the attacker much more control, only downloading specific stages once conditions such as time have been met. The diagram below shows what an attack involving multiple staged binaries may look like. So, phishing email, compromise site, entry point, that's the entry point, okay. Initial dropper file, probably a doc, PDF or RTF, and then executes what? Executes a particular downloader. I see, downloads and executes that particular file that we've just downloaded from the web, right? And that's the malware. Yeah, first stage and second stage, okay. Yeah, so jingle.net all the way. Okay, for today's task, you will be reverse engineering two .NET binaries using the Decompile IL spy. So you can follow the walkthrough below in reverse engineering using an example application named DemoX. Then you will reverse an application on your own at the end of this task. So before analyzing our target, we need to learn and find a way to identify the original binary file, modify it, or use it as evidence. Also, it is good practice to have a big picture of the file we're dealing with so we can choose the proper tools we will need. So let's start by navigating to the file location in the demo folder on the machine's desktop by right-clicking on the file named demo and clicking on properties. Okay, we can observe that the file's extension is .x, indicating that it is a Windows executable, yeah? So since it's a Windows file, we'll use PE Studio, a software designed to investigate potentially malicious files and extract information from them without execution. This will help us focus on the static analysis side of the investigation. So let's open PE Studio from the taskbar and then click on File Open. Okay, let's do that. PE Studio. PE, oh, no Z. Studio. Let's open PE Studio. Oh, bro, it's this one, right? Yeah, this one. Okay. We open that and then what? Open, select the file, open file, demox located under user administrator, desktop demo, demox. User, desktop, demo, and then demox. Yeah, right. Okay. So then what? As shown below, PE Studio will display information about the file. Yeah, it does. So let's start enumerating some of the most important aspects we can get from it. So using the left panel, we can navigate through different sections that will share different types of information about the file. In the general information output displayed when opening the file, we can see the hash of the file in the form of SHA-256, right? The architecture type in this case is 64. The file type and the signature of the language used to compile the executable, in this case, .NET framework that uses the C# language. Okay. Yeah, we do see that. So yeah, we can navigate through different sections. Yeah, so where are we going? That will share different types of information, right? So let's look through this, see what we find. This is the users property. This is the encryption, the hash, you know, for this particular form of encryption in the form of SHA. Yeah, the architecture type in this case is 64. Yeah, we can see that 64-bit, right? And the signature of the language used to compile the executable, which is Microsoft.NET, right? Yeah, that's it. So let's focus on some critical data we can obtain, right? First, if we want to identify the file and provide evidence of its alteration, we need to take note of the file's SHA-256 hash, as we mentioned above, as well as the hash of each section on the PE file. PE stands for Portable Executable, and it's the format in which Windows executables are arranged. You can learn more about it here. Okay, so these sections represent the memory space with different content of the Windows executables within the PE format. So we can calculate the hash of these sections in order to identify the executable properly. We'll focus this time on two hashes, the one from the text section, which is the section on the file containing executable code. This section is often marked as read and executable, so it should not have any alterations when the file is being copied. But we can observe them in the screenshot below. Okay, so let's go to footprints, right? And then we can see section, text, MD5, and then we can see that, yeah. A memory space with different content of the Windows executable within the PE format. We can calculate the hash of these sections in order to identify the executable properly. Okay, sure. We'll focus this time on two hashes. The one from the text section, okay, which is this one, right? We got it. And then what else? Which is the section of the file containing the executable code. This section is often marked as read and executable, so it should not have any alterations when the file is being copied. We can observe them in the screenshot below. So another essential section we can use to obtain information about the binary is the indicator section. So this section tells us about the potential indicators like URLs or other suspicious attributes of binary. Okay. Indicator section, right? This section, potential indicators like URLs. Okay. So let's go to indicator section. Then you should be giving me strings, and then like potential indicators like URLs or other suspicious attributes of a binary, right? Okay, the screenshot above shows several strings in the file, like file names, URLs, and function names. This can be very important depending on the file's execution flow. Additionally, looking for artifacts such as IP addresses, URLs, and crypto wallets can be a quick win for gathering some identifying intelligence. We'll learn about that in the next section. Now that we have information about the file we are investigating, let's try to understand what the executable is doing. We need to understand its flow. If we try to read the file by opening it, we cannot do it it's in binary format, right? In the previous section, we learned that the file is compiled using the .NET framework used by the C# language. We can decompile the binary code into C# using a decompilation tool like ilspy, right? So this is a decompilation tool. Okay. So yeah, we cannot do this. It's a binary format, right? We learned the files compiled .NET. That framework, yeah, used by the C# language. We can decompile the binary the binary code into C# using a decompilation tool like this. All right, I see that. So what else? This tool will decompile the code, providing us with readable information we can use to determine the flow of execution. Let's start by opening lspy from the taskbar and then click on File. ilspy, where's that? Okay, I see it. So you're asking me to compile this. The flow of the, let's start by opening this from the taskbar and then click on File, open and then navigate to see users and the same one as before, I guess. Spy file, open and then navigate. So, okay, this tool will decompile the code, providing us with readable information we can use to determine the flow of execution, right? What's happened, what's been changed by this binary file, right? Let's start by opening lspy, ilspy from the taskbar, and then click on File. Do we open it? Still loading up. And then click on File, Open, and then navigate to see Users Administrator Desktop Demo, and select the file Demo X, right? Okay, so let's open the file. File, Open, and then we have to navigate to, you see users administrator, yeah, users administrator, and then we go to desktop, and then we go to demo, right, and select the file demo.x. The tool ilspy may take up to 30 seconds to appear on the screen. Okay, it's working right now. Okay, we got something like similar to what they attached as the image for this, right? As we can observe from above, the left panel contains the libraries used by the framework, right? So these are all the libraries this framework has used, and the actual decompiled codes is in the section with the file name demo. Yeah, this is the actual decompiled code, right? Let's click on it to expand and see what it contains. All right. Let's see what it contains. The demo binary, right? Demo metadata references, and then demo binary, and then if we go to program, and then if we go to main string void, okay. As the screenshot above shows, ilspy can provide much information like metadata and references. However, the actual show is displayed on the bracket symbol. Yeah, symbols, right? In this case, under demo binary program main, which is what? Actually the main function of the executable. Now we have access to the code running on the binary. Let's analyze it. Okay, so what is it that we should see here? Like some kind of information that would tell me what this is doing, right? So console write out hello THM binary, then you assign this particular string to this address variable, and then also for this test you combine some things. Then you try console downloading file address file downloaded to blah 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 process start new process. All right, console image open successfully. Catch the exception is Console write line, you're printing an error, and then recur plus the x.message. Okay. All right. As the screenshot above shows, LSpy can provide much information, right? Like metadata and references. However, the actual show is displayed in the brackets, which is here, right? Using this under demo binary, where is that? The demo binary. Yeah, program main, which is here. Yeah, actually the main function of the executable. Now that we have access to the code running on the binary, let's analyze it. So the code above displays the main function in its code. We can observe that first, it brings to the screen the message hello THM demo binary using the console write line method. Yeah, we can see that here. That's the first line, right? It then uses the sleep method to wait for 5 seconds. Yeah, okay. Then it assigns a value to two string variables, address and text. The first one with the URL accessing a PNG file, and the second one with a file name on the user's desktop named thm-demo.png. All right. So the codable displays the main function. Yeah, we already went through that. We waited 5 seconds. Then it assigns a value to two string variables, address and text. The first one with the URL accessing a PNG file, and the second one with a file name on the user's desktop named thm-demo.png. Yeah, we can see those. Then we will try to connect. Wait up. I want to see this to the end. Oh yeah. Yeah, that's the file, right? What did I do? I don't want to go to special folder. What up? Okay, let's try to get back to our main program, which is this one. Okay. So finally, yeah, so we get that particular thing. Then we'll try to connect to the URL on the address variable and save the content to a file on the desktop using the web client class, and it will then execute the downloaded file path assigned to the text variable using the process class and the start method as displayed below. Process start, yeah. Okay, finally it prints the message bye-bye, leaving THM demo binary. Yeah, this is what we see here, right? Again, to the console and wait for 5 seconds using the sleep method before closing, right? Great. We now understand what the binary is doing. It will download a PNG file to the user's desktop from the URL. Let's execute the file and see if this is true. Once the binary starts, wait for the text hello THM demo binary to appear, then press enter to download the file. Note, we are only executing the binary because we are in a sandbox environment. Execution of an unknown binary on a host machine is not recommended, right? Okay, so let's just, I guess, download the file and see if it's true. Okay, let's download that. And then right click, and then just basically execute hello THM demo binary. Yeah, I see the message. After executing the file, we can observe that it was downloaded to the desktop and the message printed to the screen as expected. Also, the downloaded file is executed and opened using the default app for PNG Paint. Excellent. We successfully reverse engineered the flow of code. Now that we have some practice, John McSkitty to help investigate the alerts coming from the Wearville app.x. Put on your reverse engineering hat and help decipher the mystery behind this suspicious binary. To answer the question, you will need to reverse the application Wearville app.x, which is located where? Wearville app.x, which under the desktop. Yeah, here it is. So I guess we have to run it. So what is the function name that downloads and executes files in the Wearville app.x? Okay, so I guess we're going to be using this ilspy file. Oh yeah, hold up. I want to see what it's doing. Okay, it just executes and then it says goodbye. All right, so here we're going to be opening another file, which is going to be the file that we have on the desktop, right? Oh, it is a function name that downloads and executes files in the Wearville app.x. Let's check that out. So, okay, this is a Wearville app. Let's check it out. It has some it has some apps. So what is a function name that downloads and executes files? Fancy app. Okay, let's read through this. Okay, nothing here. Code analysis. All right. References. The function name that downloads and executes files in a Wordle app. I guess we can go to metadata. Not really. Resources maybe. And then Wordle resources.png. Not really. Fancy app maybe. Yeah, here it is, right? No, I don't think it's this one. All right. Form. What is the hint? So use the else by tool, expand the form one section, inspect each function. Oh, okay. Form one, we were just there. And inspect each function, right? So components container. No. Dispose. Bool if disposing components equal null, different than new component.dispose that downloads and executes files in the Wordle app. Download and execute file. Oh, this is the one. String, the address where you're going to be downloading the file from, and then the execute if file exists, text file delete, web client download file address.txt. All right, so once you, what is the function name? It's download and execute. Oh, file. I missed the file. All right, that should be good. Yeah, once you execute the Wordle app, it downloads another binary to the downloads folder. What is the name of the binary? The binary that you just downloaded because I executed that binary file. I guess it's Explorer. All right. So what else? What once you execute the Wordle .exe, it downloads another binary to the downloads folder. View. Hidden items as well. Nothing. P Studio. No, this is not the one. Explorer should be. Looks like it's not. Oh, probably Explorer.x. That's the binary, right? Yeah. So what domain name is the one from where the file is downloaded after running appx? Okay, let's check this out. Here. Nope, I don't want to do that. Demox, no. I'm already in the next exercise, bro. What domain name is the one from where the file is downloaded after running Wordle? Oh, the domain where the file is downloaded. Mayor C2. Mayor C2. Is that it? Oh, .thm, I guess. Okay. Then the stage 2 binary is executed automatically and creates a zip file comprising the victim's computer data. What's the name of the zip file? It creates a zip file comprising the victim's computer data. The stage 2 binary. What do they mean by that? It's executed automatically and creates a zip file comprising the victim's computer data. What is the name of the zip file? Automatically and creates a zip file. I don't know. Where is he downloading a zip file? Form, initialize, Windows, timer. To stage 2 binary executes automatically and creates a zip file. But let's try to find that zip file, right? Zip file, no zip file. THM demo, no. Documents maybe. Or maybe under downloads. P Studio, not really. What is the hint? So visit the pictures folder to check the zip file. Pictures, all right. So the zip file is collected files. What is that? Collected. Oh, come on. Here. Okay, collected files, right? So what is the name of the C2 server where the stage what? .zip, I guess, right? Yeah. Okay, what is the name of the C2 server where the stage 2 binary tries to upload files? We should be able to see that. Download and execute. And then where do you want to upload files? No, don't leave. Damn. Oh, okay. If I just click on going back, yeah, it takes me back. Okay, so what is the name of the C2 server? The C2 server where the stage 2 binary tries to upload files. Download and execute. Load image from embedded resource assembly. Okay. Error loading image resource. No. What is the name of the C2 server? Well, let's check the hint. Use the AutoSpy tool and check the download and execute file function. Download and execute file function. Yeah, so what is the name of the C2 server? Would it be mayorb.thm? I don't think so. Mayorc, enter. HTTP mayorc2.thm. Maybe. Just maybe. No. Mayorc2. What is the name of the C2 server? The name of the C2 server where the stage 2 binary tries to upload files. Environment special. Folder user profile. Then the loads. Explorer.x. If file exists, file delete web client download file. Okay. Where the stage 2 binary tries to upload files. The name of the C2 server. Mayorc2.thm. Mayorc2. No, it doesn't make any sense. Why isn't it HTTP mayorc2.thm? No, it's not the one. You're asking me for the name of the C2 server. How do I go for finding that? Form 1. And then whenever I try to get a hint, use the IL-spy tool and check the download and execute file function. Where the stage 2 binary tries to upload files. The name of the C2 server. Get folder path environment.special folder. Environment.special folder. Downloads explorer.x. Maybe it's this one. No, this is not the name of the C2 server. What are you thinking, Angel? Using web client with web client, yeah. Download file address, which is the address that you provided there. The text, process start text, and then an article with loading or executing the file. Message error, message box button, okay, Megasbox icon hand. Okay. I can't get through that, so let's check out the walkthrough video. just for this last question, right?
Hello everyone, it's Marcus Hutchins aka Malware Tech, and today I'm going to be walking through TryHackMe's. Okay, so next question. The stage 2 binary is executed automatically and creates a zip file comprising the victim's file would then downware. So you would start off with your initial entry. So I'm just going to copy the domain name and then we're going to open it up in a web browser.
Okay.
So as you can see, we've downloaded the second stage binary and now we can begin analyzing that. So we're going to do the same thing again and just drop the explorer.exe binary directly into ILView, and it's most likely .NET as well.
So where's that file? Okay, let's open that, I guess. File. Open. Let's go to the downloads and then Explorer. And then let's see what up.
So now that we have the explorer.exe binary open in ILView, we can see that it is also .NET. It's called file collector. And then if we go again to the main entry point, so in a lot of programming languages, the entry point is simply called main. In C, it's called main or WinMain for Windows applications. And then if we go again to the main it's called file collector. And then if we go again to the main entry point, so in a lot of programming languages, the entry point is simply called main. In C, it's called main or WinMain for Windows applications. In Python, it's called main. So oftentimes you can just skip straight to the function named main. In C#, it is again called main, except it begins with a capital letter. So we're going to just look through the code. So it's creating an array of file names. We have docx, PowerPoint, PNG, GIF, and JPEG.
Yeah.
Now
We managed to get it, guys.
It's getting a folder path, and this time the folder path is called My Pictures. So it's going to log searching for files in folder path. So it's going to look for files in My Pictures. Now, since it's already created an array of file extensions, we can probably assume that that is the file types it's looking for, but we won't go with that until we've actually read the code a bit more.
Yeah.
So next up, we've got path.combine collected files. So it's creating a subdirectory named collected files in get temp path. So it's getting the temp path and then it's appending the path name collected files and then calling create directory.
Yeah.
So all this is going to do is create a directory named collected files in the temp folder. So temporary folder created, and it's going to output the name of that directory. So next up, it's going to call directory.getFiles on that first folder path we created, which is the My Pictures folder. So it's going to search every file in the My Pictures folder and every subdirectory by the looks of things, and then it's going to iterate each file that it finds.
Yeah.
Now here we've got the sources.any, which if you remember we created an array of file extensions. This is basically going to say if the file ends with any of those extensions that we searched for, then we're going to, by looks of things, copy it. And then finally, we're going to create a new path again in the temp path, and we're going to create a file named collectedfiles.zip. And then it looks like we're going to use the zip file.create from directory to basically just zip up that entire directory. So in short, we're basically just going to get any doc, PowerPoint, PNG, GIF, or JPEG files from the My Pictures folder or any subfolder. We're going to copy them to the temp directory under a folder named collected files, and then we're going to zip the folder named collected files to a file named collectedfiles.zip. So there we have another answer. It asks us what is the file name that the files get put into, and that is collectedfiles.zip. So that should be the answer to the next of our questions.
Yes, it is actually. So that was interesting, guys. I learned a bit here. That's always good, right? We're here to learn. And so that's it for this video, guys. I'm sorry I've been a little bit tired because I have some past just busy days. But yeah, that's about day 21. I'll see you guys in the next day. Peace.